Hey guys, so what I have here is a keyboard.
But where are all the keys, bro? What?
It's actually a special keyboard that I made that uses this rotary encoder to swap through our elements. I made it to where each link is a command in its own array that the keyboard prints on the event where our button is clicked somewhere. I'm not only going to be showing you guys how to build it, but also program it to where it functions however you'd like.
So let's get started.
Okay, so here are the parts you'll need. Bam. First off is the SSD1306 screen, 0.96 inches, 128 by 64 pixels. It should be well. This 4-pin one works great. An Arduino Micro, or any Arduino that supports the keyboard library, preferably one that's not bent either, but I think this will do for the tutorial. And don't forget a rotary encoder. This one's just a fancy one. You press it. Also, don't forget your breadboard and your wires. Keep forgetting Arduino software. If you need it, the link is in the description below. Once you have those things, you're ready to get started. Let's cue the dramatic build montage. Great, so now that the circuit's strung out, I just wanted to point out that for some reason the pins on the software I used aren't matching the pins on the Arduino Micro that we're using. So it's essentially the same things, just for example, the pin you'll connect to pin 2 is just D2. D2 is pin 2. But the problem here is these purple wires. The wire coming from switch on the rotary encoder, which, yeah, the middle one, is supposed to be going to pin number 14. Switch goes to pin number 14, not D13. Also, the last one, which is CLK. CLK does not go to D12. CLK goes to number 16. And also, I'll have it in the code. Yeah, so because of that, I'm just going to show you guys how to build it out a breadboard really quickly. Shouldn't take more than 5 minutes, but let's get started. Your breadboarding and your Arduino. Plugging VCC from the Arduino board to the positive rail and ground to the negative rail on the breadboard. Shove that little screen in there. Hook up ground and VCC to their appropriate rails. Repeat the same for the rotary encoder. Only the positive and the negative rails should be plugged in right now. From your screen to your Arduino, plug in SCL to A1 and SDA to A0. The rotary encoder, take switch and plug it into pin 14 on the Arduino Micro. Take DT to number 4. And then finally CLK to pin 16. There we go. And just like that, we're ready to give it some code. Also, guys, before we get moving forward, I just want to let it be known that I'm using as many free softwares as possible, so please disregard any of the pop-ups that are going to occur during the next segment of the video. If you guys like the video, smack the like button, and I'll be sure to make better content with paid services if I see people are liking the content, of course. So, let's get started. And alright guys, so we made it to the last bit here. All I'm going to do here is just explain the code, so if anyone wants to make their own changes, which I highly encourage you guys to do, yeah, so you guys can do that. So, I'll just go top to bottom and then explain all the important bits, especially the arrays. So, start off, you just include your libraries for the SSD, the OLED display. If you want to use a different display, you can. This one, however, is required for this project. The include keyboard library. What that library does is it allows your microcontroller to act like a keyboard. Moving on, we need to define our rotary encoder inputs. We have CLK, DT, and switch. CLK is on 16, DT is on 4, and switch is on 14. If you saw the diagram that I made earlier in the video, you'll see that I have a CLK and a switch attached to 12 and 13. Just make sure you put them on 16 and 14 on your Arduino Micro. There was just a problem with the software I was using. I've never used it before, but I like trying new things. So this code right here, I can't really explain it. All it is a basic rotary encoder sketch, and I'm going to link it in the description where I got it. But basically, we need a counter, and what that counter is as we rotate the knob, that's going to change the counter. And that counter is what's going to be indexing through our arrays. That's going to allow us to say, okay, we want the 0th element. The 0th element is going to print this. You want the first element, which is a link to Facebook. We'll print the Facebook link, which is in a separate array. Now, we'll get to that in just a second. So we have an int for current state of click and int for last state of click. This is just to tell if it was clicked or not. A string to tell the direction of the string, and the place I got this code from will do a better job at explaining it. It's basically just a simple sketch for a rotary encoder, and It was really helpful for me getting started with rotary encoders, because yeah, I'm pretty new to all this stuff. But next, this also comes from basic sketch for your OLED. You just define your screen width, your height, OLED reset, screen address. And if you want to see the simple sketch for this, all you'll do is go to examples, and they'll check out your sketch here. Make sure you have this library downloaded, Adafruit SSD1306. You can download that in Tools, Manage Libraries. Yeah. This is also part of the sketch for the OLED. I'm sorry, I just had a brain fart. Wow. So yeah, moving on. We're in our void setup. I forgot to mention that. This is very important. The Keyboard.begin. And what Keyboard.begin does is it says, hey, microcontroller, start acting like a keyboard. And your microcontroller does. However, please note that not every microcontroller will support the keyboard library. I learned that the hard way when I had sorry, it's been a long day. When I had the Arduino Uno, my Arduino Uno connected to the same circuit that we just wired up, and it wasn't uploading. I was like, why not? And it's because only Arduino Micro and Arduino Leonardo, I believe, support the keyboard library. Not every microcontroller supports the keyboard library, basically. So keep that in mind if you want to be doing your own projects related to keyboards. Ping modes, we do that for our CLK, our DT, and our switch. We set them as inputs, serial begin, and we want the last state of our click is to be digital read click. So we're going to read the value of click. When it's clicked, well, we'll be able to tell if it was clicked. Yeah. Again, the link I'll share in the description will do a much better job than I ever could explaining it. But yeah, this bit of code just happened to work for what I was doing. So now we move on to our void loop, and this is where the actual magic happens. First, current state of our click, we're reading our click here too. What is this statement? If current click is not equal to the last state of our click, and our current state is equal to 1. So yeah, this is basically saying if we're rotating in the clockwise direction, we're going to add to our counter, or else we're going to subtract from our counter. And this bit of code right here is all really important, because this is what's going to basically limit how many counters, or the value of our counter. It's going to limit the value of our counter, excuse me. So if we want to add 5 elements, we're going to have to put 4 into all of these spots right here. Make sure this one's -4. If we want to put in 10 elements, we're going to have to put 9 in here. And that's just because when we put an object in an array, remember they start at index 0. So we're also going to want to start our counter at 0. And if we start our counter at 0 and we're going to 4, that really is 5 elements. So yeah, just always make these 1 less. Always make these 1 less than the amount of items in your arrays. And as we rotate the the knob, we're gonna be able to see it in our serial monitor. Once I was able to see this in the serial monitor, I was like, oh, okay, we can put this on a screen now. And yeah, so you can see as we rotate through the values, we're also looping through our arrays that I'm about to show you guys in just a second. And each bit in the array, there's a name array and a command array. The name array and the command array are supposed to line up. So index 0, we have it as Facebook link. This is just an example. In our string array, we're declaring a string array with 5 items. If we want to add another item, we just follow the same syntax and make sure to change this to 6, and then you would have to change these to 5. If you're changing this array, you're also going to have to change this array. And we'll get to that in just a second. Basically, what this is right here is just to display our counter. It's going to say, hey, press to print, and then in the center of our screen is going to be our counter. And as we rotate the knob, the counter on our OLED is going to change. Yeah. There's also, oh yeah, no, that's all the same thing. That's all the same thing. This is just going to show the name at the bottom of your element. So you're going to see the counter value, and you're going to see the name of that element, so you know what you're clicking on, you know? Int button state equals digital read switch. And what this allows us to do is we can conditionalize if our rotary encoder is pressed. So when we press our rotary encoder, we're gonna have to take that digital read switch, and we're gonna take that button state, and we're gonna say if button state is low. If button state is low basically means if our rotary encoder is pressed. Here's what's gonna happen. I don't know what this means. This was from the sketch, but here is our. Here is our command array. Notice there's also 5 elements in here. So, notice how index 0 is facebook.com. That's because index 0 in the name array is Facebook link. So when we want to print the Facebook link, it's going to go take the counter at index 0, and it's going to pull from the command array and the name array. I'm probably explaining this dumb. Sorry, I butchered that. This is my first time making videos, and it's evident. Sorry, guys. But yeah, basically, let me open a notepad. And let me start recording on my phone so I can... Oh, I can't record on my phone. I'm taking... Okay. Break time over. So when we want to print out the Facebook link, we'll go to index 0 on the OLED display, and all we'll do is press the button. And when the button is pressed, it's going to take the counter value, it's going to take the counter value, and it's going to go into our command array at that counter value. So if our desired link is index 3, we'll go to counter 3, and we'll press the button, and it's going to pull from index 3. And it's going to display that. And it's going to keyboard.print that. Because we're setting our string, what we want to print, to our command array at our counter value. And then we just keyboard.print what to print. And then these are just some friendly little animations that will say, okay, we're printing, please be patient, printed, thanks for waiting. And then it's going to go right back to the normal starting screen as soon as you start rotating again. And yeah, that's basically the code. Just, here, I'll show you guys how to add another bit to the code. So let's say I want to add a link, and let's make this link go to GitHub, okay? So we're gonna go here in our name array, and we're gonna say, hey, we're creating a new variable called GitHub link. You don't have to have a comma if it's the last one. We're gonna have to change the amount of variables in the array, and remember, if this is 6, these are gonna have to be 5. And we'll also have to go here, change this to 6, and then our 6th variable in the command array is gonna have to be the GitHub link, https://github.com. End it with a quote. And yeah, and then you can upload that sketch to your Arduino. Yes. Okay, so now that's done uploading on our device that we just wired up. We're on our OLED. It should show the 5th counter, the GitHub link. So now when we press it at counter 5, which is really index 6, we're gonna press it, and it's going to print github.com, which is what we put here. Whatever we put in here is what's going to be printed. It could be gibberish. Let's go ahead and upload that. So you guys saw how it was printing in GitHub. Now it's going to print all that gibberish. That same gibberish here, so you guys can see it's the same gibberish. Now let me go back to it. And then, there we go. And again, just final words, because I'm getting very tired. It's been a very long day. I've never made a YouTube video before. Ever. So this is a first. What was I going to say? Some things that you can use this for could be code bits, like for loops. You can, you can do links. You can do sentences. You can do passwords. And there's a lot you can do with the keyboard library. The way I have it set up, you can't do these things, but with the keyboard library and other projects, I have been able to do things like open apps, like games on your desktop. Like Fortnite, because I'm basic. Also, NRF commands. So like, turn on the lights. Also, if you add an NRF module, each NRF module gets their own unique their own unique ID. You can take this and add on the counter value. Simultaneously, you can have a ton of other NRF modules as receivers. Each with their own specific ID, matching transmitters. ID plus counter for NRF we want to connect to, if that makes sense. It's something I'm working on, but I think that's what the next video is going to be. So yeah, I hope you guys really liked it. I worked really hard on this video. If you guys want to see more, just leave a comment, leave a like, whatever. This was fun. So see you guys soon.